So I wanted to show an example where we solved, because I did 2 examples of radical equations already, right? But they both dealt with square roots. I want to do one where it does not have a square root, it has a cubed root. So let's do that one. So what did I say initially over here when I'm solving a radical equation? I said we want to isolate the radical expression first, and that is something that we do regardless of whether we have a square root or a cubed root. So in this case, I want to isolate this. So I'm going to add 2 to both sides. I want the cubed root by itself. So let's start there. So now I have the cubed root of x squared plus 4. This is gone, equal to 2. You could see that this radical sign ends here. So this -2 is not part of it, which is why I knew that I needed to move it to the other side. Once I isolate my radical expression, right, I note that the index is a 3. So now I'm going to raise it to the power that matches the index, which in this case is a 3, right? Before it was a 2 because it was a square root, but now the index is a 3. So we raise it to the 3rd power. And that's going to cancel the radical sign for me, which is what I want to do because I can't figure out what goes in there unless I get rid of the radical sign. So the left side becomes x squared plus 4. This cancels with this. And 2 to the 3rd, 2 times 2 times 2 is 8. And now I have a nice, beautiful little quadratic equation, which, if you recall, we do like to set equal to 0. X squared minus 8 is equal to 0. There are 2 approaches. Ooh, Jackie. +4 minus 8 is not -8. This is -4. Almost got me. There are 2 approaches to this. One is to recognize this as a difference of squares and factor it, or the other is to isolate the x squared because you can, right? In other quadratic equations, we can't always isolate. Let me see if I can find it, right? We can't isolate the x squared because we have this extra term. If we have this term missing, then we can isolate the squared term and then the constant, like here. And then you can, square root property. So this is using the square root property, and this way is using your 0 product property. Both of them work. If you recognize this as a difference of squares, it's x plus 2 times x minus 2. And from this one, when you set it equal to 0, you get a -2. When you set this equal to 0, you get a +2. You get the same thing here if you square root both sides. X is equal to the square root of 4, which is 2, plus or minus using the square root property. They both give you the same thing. Check your solutions. You plug it back in to make sure it works. But usually with the cubed, you don't have any issues because you don't get that positive and negative case. But always check your solutions. If I look at this, I could look at this and tell if a -2 or a +2 is squared, I get the same thing. So I'm going to get the cubed root of 8 minus 2. That works. So these are my solutions. Now I didn't show that. You guys can actually practice showing, the check part, plugging it in, but I wanted to at least show you a radical equation with an index other than, 2. So at least we did one with 3. In my next video, I'll do another extraneous solution case, but not difficult, right?